All right, another set of formulas, half-angle formulas. So we can see these are for angles alpha over 2, for sine, cosine, tangent. These three expressions have square roots. This is one of those cases for tangent. We've got three different options. Okay. If it's the square roots, we have to decide if we're going to do plus or minus. So we'll talk about what that means as we do some examples. But here's where they come from. So again, we're going to start from what we just finished, which was power reducing formulas, right? If we've got a square here, we can trade that for a double angle. So this is a formula on our formula sheet from power reducing formulas. So now instead of theta, we're going to let our theta equal alpha over 2. Okay, so here theta, we're going to let that be alpha over 2. So notice that this just becomes alpha. So then we take the square root of both sides to get sine of alpha over 2. Because we're taking the square root, we have to say plus or minus, right? And in the problem, we will determine if we're going to take the plus or minus. We do a very similar thing with cosine. We start with the power reducing formula, reduce theta with alpha over 2, and then take the square root. Because we take the square root, we have to take plus or minus. For tangent squared, we start with the power reducing formula for tangent squared, and we replace theta with alpha over 2. So we get 1 minus cosine alpha over 1 plus cosine of alpha. Or we can take the ratio of sine and cosine, right, to have the square root expression instead. Okay, so that's kind of where they come from. Again, you're not going to have to derive these, but it's good to know where they come from. And we're just going to apply these equations. So let's do some examples. All right, so first of all, find sine of 15 degrees using a half-angle formula. Okay, well, so we could write this sine of 15 degrees equals sine of 30 degrees divided by 2. Right? So in this case, our alpha would be 30, right? This would be alpha over 2, where alpha is 30. So sine of alpha over 2 is going to be plus or minus the square root of 1 minus cosine of 30 divided by 2. Right? So the trick here is to realize, okay, my alpha isn't 15, my alpha is 30, right? And I find it helpful to actually write this step out. 15 is 30 divided by 2, so that we say, okay, our alpha is 30 degrees. So now let's just think 15 degrees is in quadrant 1. In quadrant 1, everything is positive. So we're going to take the positive square root. And cosine of 30 degrees is square root of 3 over 2. This whole thing divided by 2. So, I mean, that's the answer. We could keep simplifying. We could say 2 times square root of 3 all over 2 divided by 2. So this is going to be 2 minus the square root of 3 all over 4. We could write this as square root of 2 minus the square root of 3 all over 2. Really, any of these are right. This is probably the best way to present your answer, but this would also be correct. Okay, so the key here is just thinking, 15 degrees, that's one of my reference angles divided by 2. So I can use a half-angle formula to find it. What about this? All right, so in this problem, given that tangent of alpha is 8 over 15 and alpha lies in quadrant 3, find the exact volume or value of the following. Sine of alpha over 2, cosine of alpha over 2, tangent of alpha over 2. So we don't know what alpha is, but we do know tangent of alpha. So this sounds like a time to draw a triangle. Right? All right, well, tangent of alpha is 8 over 15. So what's this going to be? Uh-oh, might need a calculator here. I'm going to grab my calculator. So 15 squared plus 8 squared, the square root of 289. I'm going to cheat. Is that a nice number? Is that 17? The square root of 289. Oh, it is. That's 17. Okay, great. Oh, there's one of the more obscure Pythagorean triples. 8, 15, 17. Okay. Okay, and here's the other important thing that we have to do to use when we're using half angle identities. They tell us that our alpha is in quadrant 3, somewhere over here. We don't know where. What's going to happen when we divide this in 2? This is our alpha. Where is alpha divided by 2 going to be? Well, let's think about this, the edges of this. Here's pi, right? So the smallest it could be is pi, and pi divided by 2 is pi halves. So this is going to go there. How about this? Well, how about actually we could go all the way over to here. 2 pi divided by 2 is going to be pi. So our angle, if our angle is anywhere in quadrants 3 or 4, when we divide it by 2, we're going to end up here in quadrant 2. But if we're in quadrant 2 and we divide it by 2, we're going to end up in quadrant 1. Quadrant 1 divided by 1 is quadrant 1. Okay? So, what does that tell us? In quadrant 2, sign's going to be positive and everything else is going to be negative. Okay, for our eventual answer. All right, so let's find sine of theta, cosine of theta, tangent of theta. So tangent of theta, they tell us, is 8/15. Cosine is 15 over 7, or 15 over 17. And our original angle, quadrant 3, sine is negative. I mean, cosine is negative. What am I doing? This isn't sine. That's tangent. Sine is, oh no, sine is 8 over 17. And it's going to be negative. All right, opposite over hypotenuse. In quadrant 2, oh no, sine is positive. What a mess, you guys. Oh, no. Our original one is in quadrant 3. It's negative. In quadrant 3, sine is negative, cosine is negative, tangent is positive at long last. Okay. So now let's find sine of alpha over 2. And I guess these should be alphas. All right, let's look at what our equation is. Sine of alpha over 2 is going to be plus or minus the square root of 1 minus cosine of alpha over 2. Before we figure out what this is this going to be plus or minus? Well, our original angle was in quadrant 3. Sine of alpha over 2 is in quadrant 2, like we talked about. Okay, so in quadrant 2, sine is positive. So it's going to be the positive. So 1 minus cosine of alpha. So 1 minus negative 15 over 17 divided by 2. So 1 plus 15/17. So that's going to be 32/17 all over 2. So that's the square root of 16/17. So what is that? 4 over the square root of 17. If I wanted to rationalize it, that's going to be my final answer. Okay? Anything from here on is really correct. Okay, this is all just kind of simplifying. Okay? So things that are tricky about half angle, figuring out if it's plus or minus. Okay, the way you do that is you think, okay, alpha over 2 is going to be in which quadrant? If it's in anywhere over here, it's going to end up in quadrant 2. If it's here, it's going to end up in, if it's here or here, it's going to end up in quadrant 1. Okay. All right, then what if we wanted to find cosine of alpha over 2? Cosine of alpha over 2 is plus or minus the square root of 1 plus cosine of alpha all over 2. In quadrant 2, cosine is negative, so I'm going to choose the negative. Plus negative 15/17 all over 2. So let's see, 17 minus 15, this is going to be the square root of 2/17 divided by 2. And it's going to be the negative. So negative 1 over the square root of 17. And let's just leave it there. Oh, look, you can't see. That's what it looks like. Okay. All right, and then finally, to find tangent of alpha over 2, let's look at our equations for tangent of alpha over 2. I don't know which one to choose. Let's choose this one just for fun. So this is going to be sine of alpha over 1 plus cosine of alpha. Okay, so let's go back up here. Our sine of alpha is negative 8/17. And our cosine of alpha, we're going to have over 1 minus 15 over 17. In this case, we don't have to choose because these signs will take care of themselves. Okay. We don't have a square root. All right, so this is going to be over 2/17. So this is going to be negative 4. Is that right? Let me look at the answer. Yes, right. Okay, so that's the end of using these half angle formulas. Okay, so if they give you one of the trig identities, draw a triangle, write out. You see how writing this out is kind of important. I mean, you can just refigure it out every time, but you're much more likely to make a mistake. Write out your 3 trig ratios, and then you're going to plug them into the formulas that you're always going to have access to. The only tricky part is figuring out if it's plus or minus if you're using the square root.